Okay. Let's see what we can get done here. What screen are we on? We're on that screen. Let's get a robot happening. Cargo run. No, cargo road. And we got some overlay action. Actually, hang on. I need this screen and I need some mirror. That goes to screen 10. That stays here. We run the overlay and we move it to that screen. Hey, it's all manual. If only we automated it. If only we were some kind of automation professional that knew how to do these things. If only that were the case, but it is not. Actually, it is, but I'm lazy or something. Okay. Let's see. What do we need to do next? Do we have sound? We do. Do we have chat? We do. Do we have Discord? We do. We do. We were talking about contributions to Bevy and why people should do it. And we go to my Discord. Oh, who did a thing? Someone did a thing. Leaf. Leaf did a thing. Yes. People should follow Leaf. Likeable Leaf. But there's no point in shouting out because no one's here yet. Okay. What do I do next? Oh yeah. Working on learning about compute shader. Wait, that doesn't take an apostrophe. Bummer. Okay, and we go to Bevy Streams. We go to Bevy Streams and we find the thing. I'm so late starting today. Had to do the shit. Had to do all of the shit. As if flailing about trying to understand fragment shaders wasn't enough. Let's add some complexity with compute shaders. And what did we get done yesterday? All the way home. Here we go. So 2025 01 day. What is the date today? It's 20. So that was the 19th. Day 29, I guess. Well, we tried rendering to an image, but this approach is not the magic solve we thought it was for having a source of truth image to do collision detection with. Turns out, image data on the CPU side doesn't change when you render to the image using a shader on the GPU side. Instead, you have to make a fairly costly copy from the GPU. I want to say frame buffer. So next we look at the compute shader collision detection approach. Did learn about render layers. Something else that we learned about. Render output. What do you call that? Oh yeah, render targets. Image versus window. And camera order used to be priority, being set to -1 to make that camera render first. Got to keep writing these things down so you remember them, or at least you look back and you see what you've achieved. So otherwise it's hard. Sometimes it's hard to remember what you've achieved. I find. So we move Discord out of the way. And then I don't know what the hell is going on here. I think there's an edge service that's still running somewhere. Because Kerberos, what the that's so weird. It's too late to do a restart now. What process is doing this? It's really strange. I launched a actually we'll close this terminal, that might help. I launched a bottles process to run a game from there. And I thought I killed everything, but apparently not. Okay. Now, let's see. We could do a blue sky post. Our ads have already run, so that's good. Gets them out of the way. No more pre-rolls. And did you think we already had enough complexity? No, I say we don't. Therefore, having mastered the art of the very simple 5-line fragment shader, today we move on to mastering the art of the very simple 5-line compute shader. It can only lead to great success, right? I'm going to run out of characters, aren't I? But I have a very short Twitch name. Aha! It worked. Okay. Who followed me? Oh, a Protogen VTuber. Well, that looks cool. All right. Who's on this morning for our team? The average goob. Gotta love it. Yes. Okay. Now then, we have the fragment shader, WGSL. Mouse shader. There we go. We have our mouse shader working. The reason we know it's working is because we can do this. Hurry up, Rust Analyzer. And the nice thing about the work that we did with the fragment shader, with the render to image, is that we can use it for our mini map. I've just realized we can totally use it for the mini map. Oh my God, let's figure that out, because that's cool. I love it. We can use it for our mini map. Hey, Lond, how you doing? Welcome back to the disaster of me learning to write shaders. We can totally use it for the mini map. So we're gonna revamp some shit. Mini map render target. Yes. Mini map camera. Yes. Ah, I knew this was going to come in handy somewhere. I knew it. I just knew it. I just knew it. Let's see. We've still got to do a bunch of refactoring, but we can. That's not a problem. We can totally do it. This is not going to be a blended GPU result to render target for collision detection. We're going to render to image for minimap. And then we're going to do minimap texture, because this game absolutely needs a minimap. So if we look at, and actually we might be able to play around with the viewport for it too, because where is it? If we go to images Google card, and when we look at lemmings, because if you just search on lemmings, you get a bunch of picture of lemmings, which is cute, but not what we're after. So this, I wonder, this kind of area here, it shows where you are, but it also shows the rest of the map. I'm not sure. Maybe it'll be helpful. Maybe it won't. Because for this to work, you would have to render the entire image rather than just the bit that you're looking at here. But the entire image is not that big. It's just a 1080p screen. So I don't see why you wouldn't be able to render the entire image and then display a limited viewport of it as the main game screen and then echo that down here. It'd be an interesting little piece of code to write. That could be fun. So let's just roll with it for now and just say that we're going to use this for the minimap. So this is going to be that. Now, why do I do that? Oh, because I need to set this. I see. Render texture is not a great name. It strikes me. I wonder if it would be reasonable to do something like, I don't suppose, because we're using mini tiny bale, I wonder if we can get away with things like this. It does seem to want to let us. Yeah, no, this is where we run into trouble. Actually, what if we clone it though? Yeah, that's where we run into trouble because of the macro. I do believe. Yeah, it's not typed and it couldn't be typed. I wonder if you can determine that though. It's going to be handle image, right? Is it going to be handle image or it's going to be image? Yeah, it's not able to do that. I don't believe. Interesting. Let's look at TinyBale's examples real quick. Because they do things like increment the value that you get back from it. But I think it's difficult for it to type that value. So if you can do some inference on it, great, but otherwise maybe not. Whereas if we declare it as mutable, maybe. So let's try. Let's try this. Oh, but we wouldn't want to mutate it. We'd want, would we? Interesting. That might mess things up. I think what we actually need, rather than having a clone of the same image, because we're no longer trying to like directly manipulate that image, what we'd want is just a new image that can take the render output from the current one. So that's where you end up with the pattern that we used in the example, which was render target example, this one, because we got that working. So we would need this. The copy source, copy destination might not be correct. Almost looks like it's going to storm outside. Which is this? This is playing, and then we're going to go to render target example. Beautiful. Okay. So target images. Yeah, okay. So let's mess around with this. Let's do this. Question mark, because to do, can we do the lemmings-like thing of displaying a viewport within the larger image? Question mark. So mute image is going to be, size is going to be extent 3D, width 1920, height 1080, default. Legend. All right. So This may not be correct. Feels like we need DST, but not source here. Find out for sure. Okay, so that's going to be image. And then instead of target image, we're going to say mini map. Wait, what is target image on this side? Target image is image render. I see. So instead, we're going to use the resource. The resource is going to be called it's called minimap render target texture is what we're looking for. So let's call it mute minimap res mute minimap render target. I love that we could potentially get a use out of all the work that we did yesterday, even though it's not quite working out the way we'd planned. I still like it. I like it a lot. I love the serendipity of that. Okay, so now we can, instead of target image texture, we're going to do minimap texture is images add image. Yeah. Then we don't need this or this or this or this. Note that this is now a separate asset to the level terrain image we used for the shader, for the level material. Now that's an unnecessary comment. We know that. Now we do not need to insert the resource because we've already initialized it. I think we'll test that theory. Now, the minimap camera. Instead of this, we're going to go, we'll tag it. I don't know if that's strictly necessary, but we can always find out later. So let's go with, oh, we do have a component minimap camera. Wow. Camera 2D. The camera is target, minimap, texture, clone, into. Clear color, color white. Now we decided not to do that in the, although I actually think it still works, but I might test that theory. Render layers is going to be layer 0 because this is the source layer. And we're going to render to the, the sprite that we generate is going to be on layer 1, I think. Okay. Now we've got some imports to do. Nice. Okay. Now. Okay. So the debug, now hang on, we need to get our render layers right. So everything stays on render layer 0, except for two things. The destination camera that shows it, that's the one without the target. That's the main camera. And the destination image is render layers 1 as well. Also, render layers 0 camera had an order of -1. Where is my camera? There it is. 29. So order -1. Oop. Render this first. Source camera. Obviously, we're going to have to split this all up into different modules and things. I just want to get it working first. So I thought I was going to do compute shaders today, and I may still, but I want to do this because I want to preserve the work that we did yesterday and maybe make it work for us so that we don't lose it. So this is now minimap texture clone. And this is supposed to be on render layers 1, along with the main camera. The main camera may need to be on render layer 0 as well. And that's because it needs to see the big screen, but also the minimap. So I'll be interested to see how that goes. I'm hoping it's okay because it intersects both of them. Yeah, so the main camera. Main camera. And we can't put the source camera on both layers because then it would show, it'd be like a never-ending loop, I guess. Actually, I shouldn't use the names. I should just, well, this is effectively, we shouldn't need the comments because we're using name components. This one is main camera. We may also need to mess around with, now we actually need to modify this elsewhere because it's not in this file. Otherwise I'd be adding a third camera. So let's go with struct main camera. Here we go. Is default UI main camera, but it also needs a render layers now. Layers from layers. Zero and 1. Okay. So if I'm right, this camera needs to see both the main screen and the minimap. Let's call it main camera. It's also the default UI camera. Yeah. Okay. I mean, we can but try it, right? Who knows what will happen? Stop that. Who knows what will happen? Any other errors that I've got going on? Yes. Yes, I do. Terrain render target is now minimap. Render target. Nothing else happening in there. Cool. So let's review here. We've got the level, which is our custom material. The level is on render layer 0, the main layer. And it's got our shader stuff in it. Then we've got the minimap image, which is our render target, and that's being added separately. That also is going to be spawned into layer 1. The source camera is, now hang on. Yeah, the source camera has a target of our render target, but it otherwise is on layer 0 so that it can see everything else on the main screen. It's also state scoped. We should make sure the rest of the stuff is state scoped. The debug image is on layer 1. It's the only thing in here that's on layer 1. But the main camera is also on both layers, so it can see everything. I'll be kind of excited if this works, to be honest with you. Okay, let's see what happens. It'll probably break. Because that's how things go. Oh, it broke. Yep, we've got some stuff in physics that needs adjusting. Okay, this doesn't exist anymore. Oh, yeah, and we don't even need this because we were wrong about this. We want main. I'm telling one of our friends is walking past the window. I'm just trying to get her to be quiet so the dogs don't notice and start yelling. Oh God, it's a life, I'll tell you. Who'd have dogs? Okay. All right, so we don't need terrain render target. We don't need minimap target. We do need main camera. Oh, this. So hang on. What was I using terrain for? Oh, I see. Right. So this actually will probably go away. But in the meantime, we could actually leave it there because it's not doing any harm. It's just using a copy. No, it will do harm because it'll be 0. Everything will be set to 0 because we're using this kind of image now. What do I do instead? I do. Actually, no, let's use it because it'll fall straight through and it's fine. It doesn't matter because we're going to do collision detection. In fact, let's just turn collision off entirely. We're going to try doing collision detection in a compute shader. So all we're going to apply is gravity. One thing we could do is keep the system around because this could be where we pass the character positions into the shader. So we'll have a think about that. But in the meantime, doesn't need to be there. Okay. Cool. It's back. Our mini map is back. And it's falling all the way through. Very cool. I like it. That's fun. And it does turn out that I keep forgetting the name of the background color. Overlay, not overlay. You said it on the camera. What the hell is it called? Clear color. The clear color doesn't matter. Let's try removing copy source. Still works fine. What happens if we remove copy dest? Got to experiment with these things, otherwise you never find anything out. It still works. So why would we need it, I wonder? Now, here's a question. Could I somehow reduce or set the viewport on the main image, but not on the destination image? That would be an interesting trick, but I don't think we're going to play with that today. What's the time? 9:28. Okay, cool. So we will add that back in. Oh, yeah. So we should find out why we didn't need copy dest. Allows a texture to be the destination in a copy buffer to texture or query write texture operation. So why didn't we need it? Because I'm still rendering to it. Just out of curiosity, if I take away in main camera, which is I think is in lib for some reason, if I take away the render layers and just put layer 1, do we still get the minimap? Oh, well, we don't have any UI camera anymore. I don't suppose I can click on it still. No. Damn it. I need a third camera. I suppose I could, just real quick. Just for debug purposes. Keep it on layer 0. The spirit of experimentation is alive. Interesting. So this is interesting because the main camera is no longer on layer 0, but this still works because there's another camera now. Shit. Oh, camera order ambiguities detected. Shit. I can't display the UI and test this. Or can I? Or can I? Or can I? What would happen if I despawn this camera on the way out? This is, I feel like this is going down the rabbit hole a little bit, but let's in playing in net, because this runs on enter in game. Here's default UI camera. Oh, what did I do? Oh, whoops. There we go. So the first thing we do is commands entity cam despawn recursive. This is so wrong. What did I do? Right. Okay. Let's see what happens now. Ah, see now we have everything, but the main camera can't see. So the render target still exists. We can see it does, but the main camera can't see the main view. So I still don't understand why copy dist wasn't necessary. Why wouldn't you need it? Huh. Because we're very clearly rendering to our image, seems to me. But for some reason, we didn't need to have copy dist set. All right. Well, it was an interesting experiment. Let's get rid of this. Make this the default UI camera. Again, change this so that we don't need to despawn the camera. And we should be back to our main state. Except we're not. Why not? What did I do? No, no barking. No barking. Quiet dog. Yeah, we don't need to bark. Come here, Papa. Come here, please. Good girl. I've got treats. Good girl. Yes. Quiet dog. Excuse me, training my dog for one moment. It's important. It's very important. Actually, let's just do this. Oh, that dog is the good dog. This dog under the table is the bad dog. Yes, you are. But you need to be quiet. Quiet dogs get treats. That's right. Good dog. Good girl. That's the good dog. The bad dog hasn't been, she's not a bad dog. That's a terrible way of putting it. She just hasn't been out for a walk today. Okay, now. Oh, I see, because we didn't change the render layers back. There we go. Now we should be good. Okay, nice. Collision detection completely broken, but that's fine. That's what we fix next. Okay, let's commit all of this shit. Yeah. So we're going to say render to image target for minimap. Nice. All right. Wait for get LFS to finally catch up. Come on, get LFS. You can do it. There we go. Yeah. Okay. Now we need to learn about compute shaders. So as I understand it, for this to work, I have this fragment shader. What am I doing? I have this fragment shader and I would like the output of the fragment shader in order to do collision detection. Now, broadly speaking, I think that I can do that by passing its output in here, but I need to understand whether that's actually true or not. So, I don't know, use output fragment shader in compute, question mark. I might need to direct this to a communicating between graphics pipeline and compute shader. You dispatch it from the CPU, which I'm planning to do. Might need to ask an LLM to summarize some of this. Convert fragment shader to compute shader. How do you pass data to compute shader? Can you send data from, I know you can send from vertex to fragment, but I don't know if you can send from fragment to vertex. Oh, you can, using input and output variables. Okay, let's get Claude to see if it can generate a summary. I have a working WGSL fragment shader. The output from which I would like to use in a compute shader. Demonstrate the approach. Storage texture. Right, so you would output to a storage and then use the storage in the compute shader? This is looking complex. We use the healthy grain of salt that we always use when dealing with LLMs because we don't trust them as far as we could throw them. We're looking for the nuggets of truth in the sea of bullshit. Create a storage texture, modify the fragment shader to write its output to the storage texture, set up a compute shader that reads from this texture. Can a compute shader instead read from, I don't know if this is even a sensible question, but from a frame buffer? Create the frame buffer texture with the appropriate usage flags and ensure proper synchronization. The frame buffer texture needs both render attachment and texture binding usage flags. It's more efficient because it avoids an extra copy. It's already in texture memory. Modern GPUs are optimized for this kind of render to texture workflow. Okay, let's have a look at this code in an editor so that we can try to understand it. It's possible there's going to be some barking. We'll try and interrupt it. Because we're doing training, we like to train our dogs not to bark. Hi, puppy. Good girl. Quiet girl. Quiet dogs. Yeah. Quiet dogs. We like quiet dogs. Okay, so we'll copy this. And we will just open some random assets, shaders, collision. Okay. This feels way more complex than I would like, but JavaScript TypeScript setup. What the Okay, no. No. Okay. Let's get a bit more specific. Construct a Bevy program using a fragment shader on a custom material. Keep everything, prioritize simplicity. Demonstrate how a compute shader could be used, could make use of the output of the fragment shader. I have a suspicion that I'm asking the wrong questions. I also know that it's going to have a very early version of Bevy, and that's not awesome. Okay, so its custom material just has a color. It's sending what I assume is red. The compute shader has an storage buffer output and a render device. I see. So we should be able to access the compute shader here. The custom material shader just returns the color, which is cool. The compute shader reads an input texture and outputs some data. It gets the texture dimensions of the input texture, gets the coordinates that it's working with. Okay. And then it's got a custom render pipeline. Creating a texture. So render to an image again. I'm also going to be looking at the Game of Life compute shader to see if that's helpful for us, but I'm reasonably confident some of this is going to be out of date. Fragment shader writes to a texture with appropriate usage flags. The compute shader reads from this texture and writes to a storage buffer. The render pipeline. So this is kind of what we were talking about with render to image, in that we're still rendering to a texture, but it's on the GPU side. Create the shader files in your project. Point 12. That's getting further and further updated. That's kind of cool. I think it used to provide us with 0.8. Compute shader results can be accessed in the process compute output system. Just curious, is 0.12 the latest Bevy version you know about? April 2024. I see. Interesting. Hmm. Create the bind group. All right, let's look at the setup code for the Compute Shader Game of Life demo. I don't think I want this. Collision detection. Okay, so Bevy, Compute Shader Game of Life RS. So let's look at a few basics. Some window sizing. No VSync. Huh. We've got some window sizing. We've got a new image, which is going to be rendered to texture stuff. Copy destination, storage binding, texture binding. While I think of it, I'm just going to add back copy to destination to mine. I don't know why it didn't appear to be necessary, but I'm not going to trust it. Might be a good Discord question to ask at some point. This even seems to work without copy dest. Ask Discord, question mark. Okay. Where is my example? Here we go. Okay. So add 2 copies of the image because Game of Life uses both of them to represent the current and next generation of the cellular automata. Try saying that 10 times fast. Then we create a sprite for the one that's being displayed. Image O. This is actually a really good example for what we're trying to do. So it's good. Actually, I like this. Transform from scale, Vec3. Yeah, cool. Camera 2D, Game of Life images. I wonder who wrote this originally. I mean, obviously, people have been editing it since time immemorial. I wonder if it was Thierry. Lots of very smart people have worked on it anyway. Okay. So, and then we insert a resource to track the things. That's fine. Switch textures to display every frame to show the one that was written to most recently. Oh, that's interesting. So it's hovering between them. That's kind of cool. Okay. Then we get the plugin. Extract the Game of Life image resource from the main world into the render world for operation on by the compute shader and display on the sprite. Extract plugin Game of Life images, and the images is the right. Interesting. So when we look at the shader for it, if we can find it, There it is. When we look at the shader for it, we've got texture binding O is a texture storage 2D, and binding 1 is a texture storage 2D. And when we run this, it's transmitting two textures every single time. And when we run it, in case there were any worries about it being too slow, game compute shader game of life. I mean, it's super fast. Granted, the resolution is not incredibly high, but it's still cool. It's interesting that some of these look like they're not using pixel nearest, but maybe that's intentional. It does look kind of cool. I love this example. It's so good. I wonder what the resolution of this window is. I mean, if it can do this, then what am I worried about? It's sending two textures every single time. I guess the ergonomics you're giving up is that you're having to develop logic in a WGSL shader instead of in Rust, which is not amazing, but you know, we'll do it anyway. Interesting that, hang on. If it's doing this, how is it getting the textures each time? It's not. We're not sending the textures back to the CPU. We're just adjusting them here. So these are all compute shaders, or is there a fragment shader in here? Because I'm starting to wonder if we need the fragment shader. This is going to be such a dumb question, but I'm totally going to ask it. Can compute shaders do the same things that fragment shaders can do? For example, take the following fragment shader and explain if an equivalent compute shader could be constructed. This is a learning question. It's fine to ask questions that seem dumb, he said emphatically. Trade-offs. Okay. So while it does that, I'm going to make a cup of tea because it's time for ads. Good dogs. Such good puppies. Yeah, good puppies get treats. Good puppies. Okay. Let's see what we got going on here. So, trade offs, considerations. Fragment shaders automatically handle the transformation from clip space to screen space. In compute shaders, you need to manually handle coordinate transformations. The compute shader example assumes a simple mapping. In practice, you'd need proper transformation matrices. Both can use texture sample. Compute shaders need to manually calculate UV coordinates from pixel positions. Oh. Both have access to the same sampling. Fragment shaders benefit from hardware rasterization and automatic primitive culling. Compute shaders run on every specified pixel regardless of visibility. That could be a big deal. Fragment shaders integrate more naturally with the graphics pipeline. They write directly to the frame buffer. Compute shaders need explicit output texture binding. More flexibility in memory access patterns. The main challenge in converting this particular shader is handling the coordinate spaces correctly. In a compute shader, you'd need to pass in the transformation matrices. Provide an ELI5 for hardware rasterization. Think of drawing a triangle on a piece of paper. You need to fill in all the little spaces inside the triangle with color. Now imagine doing this for thousands of triangles that make up a 3D game. That's a lot of coloring to do. Graphics cards have a special part built into them. Okay, this is a little patronizing, but thank you. Like a super fast coloring machine that's specifically designed to do this filling in job. This is hardware rasterization. It's like having a robot that knows exactly which pixels need to be colored in. Interesting. When you use a fragment shader, it works together with a special coloring machine. I said ELI 5, not ELI dumb 5. Compute shader doesn't get to use the special coloring machine. Okay. I see. All right. So the example that it's come up with is probably not going to be that useful. Yeah. Well, riddle me this, Batman. Let's consider the reverse. Could a fragment shader be used to do collision detection using a paintbrush to detect if two objects are touching? You can only run on pixels that are actually being drawn. I see. No, I would not like you to demonstrate those things. Interesting, though. Okay, so distinguish vertex shaders from compute and fragment shaders. Run once per vertex. Primary purpose is transform vertex positions from model space to screen space. Interesting. I think that's a useful mental model. Once per vertex, once per pixel, an arbitrary grid. Interesting. Okay. Data flow, vertex, tessellation, geometry, rasterization, and fragment. Huh. The gatekeeper of the graphics pipeline. It's where 3D positions get transformed into screen space before everything else can happen. Fragment shaders paint the pixels, and compute shaders are the generalists that can do almost anything, but don't get the specialized hardware benefits of the graphics pipeline. Huh. Okay, that's actually a really good description. Um, is there, this is going to be such a stupid question, such a thing as a tessellation shader? Huh. Wow. Terrain or water rendering. More triangles closer to the camera. Ah, WGPU doesn't support it. Interesting. Which kinds of shader does WGPU support? Which kinds of shader does, yeah, something like that. Just the three. Okay. Yeah. Okay. Well, it's very interesting. Vertex, fragment, compute. Vertex, fragment, compute. Cool. All right. So let's go back to looking at the compute shader game of life example. Specifically, we want to look at interaction between, I don't think it has a fragment shader. So it's not a good example in that respect, but I think it's a good example in terms of um, getting a texture buffer back and forth. The work group size thing is, I think, a little tricky for me. I'm going to have to figure that one out. But I'll use default values where I can. So it gets a location as a vec2. What is the invocation ID? Is it importing anything? No. Counts the number of alive things in that location. So it's going to look at around itself, basically. So count alive checks a bunch of different locations, which is great because we can use similar things to this to look at what's below the feet of the character and what's in front of the character. Because we're going to need to check the pixels immediately in front of it as well. Mike Daly was showing how the original Lemmings just checks the original Lemmings just checks the ground immediately underneath the character, but also 4 pixels in front of the character. And if it's 4 pixels in height, then it can't climb over it. So it wouldn't be able to climb over this. And it would have to stop, turn around, and go the other way. What we need to do is extrapolate that because our sprites are bigger. They're not like 10 by 8 or whatever he was using. They're more like 32 by 32, I think. So we would need probably a larger, well, not that large, a larger cliff. We might double it, say, or triple it. And we need to be able to look ahead around the point specified by maybe the feet and say, okay, let's look, say, 10 ahead and 10 up and see if we can find an alpha pixel. And if we can, there's no collision. If they just jump up. But if we can't, then we need to do something about it and turn them around. And we need access to that in the Bevy side. So the compute shader needs to be able to communicate back by returning a buffer containing a bunch of collisions, I guess. I'm not even sure on the details there. So the important thing about that is that we should be able to detect kind of shallow shapes that the lemming or whatever can walk out of, as opposed to shallow shapes or deeper shapes that it can't. So it gets stuck and has to walk back and forth. And then we tune that until we have behavior that we want in terms of how easy it is to get turned around and kind of fall into holes and get stuck and that kind of thing. Yeah. Okay. This is interesting. So yeah, this kind of thing could be very useful to us. We don't need 2 buffers though. We should only need 1. Texture store output, location, color. So let's look at texture store. We can't even use go to definition in this thing, because these are just compute shaders. Texture store is just WGSL. Texture store and texture load look like they come from WGSL. And I guess they operate on our texture storage 2D. It should only be read. So let's look real quickly at what the LLM suggested in terms of a compute shader that accessed the other one. Accessed the fragment shader output. Right. Using a fragment shader on a custom material, prioritize simplicity. Compute shader, the fragment shader writes to a texture with appropriate usage flags. The compute shader reads from this texture and writes to a storage buffer. The render pipeline ensures proper synchronization. So this is kind of, yeah, this is kind of something we should pay some attention to. So I think we will, I think we'll create a new plugin called, will we do it in the physics? We'll probably do it in physics, right? Because that's what it is. Okay, let's go physics. And this will give us some room to play. So let's grab this. Version 1 of 2. We want version 2 of 2. We'll copy that and just see what it is in our own editor. We can get rid of this and convert everything away from bundles. And we've got a gravity plugin, so we'll get this and add it here. Don't need that. Don't need that because we already have that material. we would like init. Process compute output. Okay. I think we want to run this on enter screen in game. Add some commands because we'll almost certainly need it. And in fact, now we can get rid of this. Custom material with fragment shader we've already got. This is just spawning cameras and doing the custom material. So we actually don't need that at all. Compute shader system. Compute shader system. Derive resource. Compute output. Okay, so let's go with collisions. Buffer, storage buffer. What is storage buffer? Render resource storage buffer. That sounds like something we should have. Missing generics. Interesting. Let's look up storage buffer. And in fact, let's look up the change log. Well, hang on. Let's get storage buffer first. Where T is shader type. Interesting. Stores data to be transferred to the GPU and made accessible to shaders as a storage buffer. WebGL2 does not support them. Does my compute shader do this? My game of life do this? We don't need this anymore. Or this. No. Texture storage 2D. Game of life pipeline. Wine group layout entries sequential. Shader stages compute. This is good. We can set up our pipeline like this. But we don't use storage buffer. Let's search on storage buffer for... I just like looking at these pictures. Examples that use storage buffer. Here we go, GPU readback. That sounds like exactly the kind of thing we'd like to do. Simple example demonstrating the use of the readback component to read back data from the GPU using both a storage buffer and a texture. Maybe I should have been doing this all along. Hey, here's my cup of tea. The things you discover, eh? The things you discover. It's high time we did a shout out for somebody. Hexadigital. Excellent. Ooh, I don't know if I follow Riccardo Strike, but I do now. Although, as a Spanish language channel, I think my participation will be fairly limited, but I still want them to succeed. So there you go. Okay. Now, ba-doo. This is good. So read back, you say, read back. GPU read back. Let's look at that. Oh, it's very simple. The actual work it does is not important for the example. Var storage, read, write, data, array U32. Var texture, texture storage 2D, write. Interesting. So potentially I could send the image. There's so many possibilities of things you can do. Oh my God. I could send the image back as a texture to be read on the CPU side, but it might be expensive. So let's just send a storage buffer with some data in it. Okay, cool. So we also want to open up GPU read back RS. So that we can see storage buffer. GPU's shader storage buffer. Why do we have these two different types? Prepared as a render asset and uploaded to the GPU. Prepared as a render asset and uploaded to the GPU. God damn it. It's got a buffer descriptor, render asset usages, and option data vec U8, as opposed to just a buffer. Okay. I wonder if the docs help me out there. This is equivalent to buffer vec T. Falls back to a dynamic offset uniform buffer with the largest array of T that fits within a uniform buffer binding. Dynamic storage buffer. WebGL2 does not support it. Does it matter? Does it have to be WebGL2 if I'm going to run it on itch? Dynamic storage buffer takes care of serializing the inner type to conform to these requirements. Each item pushed into the structure will additionally be aligned. Oh, that's convenient. I think this is a good Discord question. I move this to here. Yes, I do. I move it to here and then I go here and then I go to rendering. Rendering. Here we go. Hello. Trying to learn more about compute shaders today. When selecting a storage buffer type, I see that we have dynamic storage buffer and we've got GPU array buffer, but what was the one that was being used? Shader storage buffer and GPU shader storage buffer. Is dynamic storage buffer it's from Bevy render resource. And this one is from Bevy Render Storage. And then we end up importing everything from Render Resource. What? Okay, I don't suppose dynamic. No. Do we have an example that uses dynamic storage buffer? Wow. Spelling much? We do not. So I'm getting confused about the difference between the types in storage and the types in render resource. Let's look up GPU shader storage buffer. Prepared as a render asset and uploaded to the GPU. And then what about shader storage buffer? Okay. In render assets, and then and some other storage types. In render assets, and then we have GPU shader storage buffer and shader storage buffer in where are they again? In storage. The GPU readback example uses the latter. Can anyone help distinguish between the types in render assets and the ones in storage? I'm a little puzzled on the difference. Additionally, if I need to publish, if I need play on web, e.g. etch, is etch WebGL2 or is it something else? Because when we run the examples in Bevy Engine org, we have either WebGL2 or these are the WebGL2 or WASM just WebGP2. WASM plus WebGPU, which I think is what itch would be using, right? Yeah, that's a big, long, sprawling question, but never mind. I'm not sure if this browser is set up for the WebGPU stuff or not. Apparently not. Oh, no, it is. Nice. Okay, cool. Right. So, what's the time? 10:28. Cool. We've still got time. Let's move this back over here. Sweet. So the readback component. We send a buffer to the GPU of U size 16. Actually, we should run this example just to do the thing. Cargo run example GPU read back. Whoa, check it. GPU at work. That's so cool. I have no idea what I'm looking at, but it's very cool. So buffer and image, right. So the image is being used to store the same information, but the rest of it is zero packed. Very cool. Okay. So yeah, that does look kind of useful for what we're trying to do. How would we store the information if we were sending it back in a buffer? We'd need an entity ID, but it would have to be that just a string or something like, not a string, some kind of entity ID and whether or not they had collided and what they collided with. All we really need to know with the collision stuff is, what do we need to know? Let's write this out, because we need to understand our mental model before we create anything else. What do we need back from the compute shader? Ground collision. We need to know when to stop falling. Forward collision. We need to know when to turn around. If falling and collision occurs, stop falling. If walking and collision occurs, turn around. Given the above, we may not need to know much about the collision itself, only that it has occurred. Is that true? Have I said a true thing? I feel like I've said a true thing. Mm-hmm. Yeah, because if we look in our model, let's see. We're here. Our little blob with legs is here. We don't care if there's a forward collision. We don't care about this stuff because we're falling. I mean, we could just fall through something, right? We only care if we get stuck on something on the way down. So if there's a horizontal collision, if we're here, then we don't care about forward collision because all we need to do is stop falling. If we then take a step by 1 pixel and encounter a wall, then we turn around. So it's fine. Because we turn around because we're already in the walking state. And you could use that for most things. Like, for example, if they're in a blocking state, and they get collided with, I don't know, maybe they explode or something. But you would also say, you would also have to detect a collision between other characters and the thing in the blocking state. You might even have to draw like a fake wall or something. I don't know how you do that. You might actually control that in the CPU rather than in the terrain. Yeah, you'd have to, I think. So you'd have collision on the CPU side as well as collision on the GPU side. But for these purposes, all we need to know is, does the character collide with something? If so, change its state. Right? So has a collision occurred? Yes. Okay. Stop falling. Has a collision occurred? Yes. Okay. Turn around. Those are the 2 rules we need to follow. So I think that works. I think this is okay. Oh, it's rubbish day. Okay. We can do any finer detail collision, e.g. with blocker characters, um, between blocker and non-blocker characters. On the CPU side with no dramas. Okay, cool. So that's a useful piece of mental model because now we can, all we need to return, we just need to return an identifier and an on-off bit determining if the preceding identifier has collided with something. Okay. I like that. It's simple enough to work. I think. Probably, maybe, possibly, potentially. Okay. So how do I do it? Let's continue our journey into compute shaders. Actually, this is a great place to put that comment. We need to know when to stop falling. Yeah. So would we store entity IDs? Entity IDs, can they be converted safely to a integer? Let's go see if anybody responded to our diatribe on the Bevy Discord. It doesn't look like it yet. We'll do, we have to wave hi to the people in introductions. Done. And right. Okay. So let's go back to looking at our example. Compute shader game of life. No, let's close compute shader game of life for now and just look at the communication example because it's so much simpler. We'll get more complex later. In fact, we're even going to delete all of this shit from Claude and just use our examples as source material. In fact, we can close playing for now too. And our mouse shader. Okay. Extract resource plugin, readback buffer. I think that's true. GPU readback plugin. Oh, that's in this example. Okay. Build and finish. Interesting. So it stores everything in finish. Interesting. Why does it do it in finish? I find this curious. Finish adding this plugin to the app once and for all. Once all plugins registered are ready. This can be useful for plugins that depend on another plugin asynchronous setup like the renderer. Interesting. This also has a bug in its, well, not a bug, but a typo in it. It's got a hard new line in here. Two hard new lines, in fact. In finish. Let's see if we can find that in Bevy. Maybe just find that text in the Bevy repo. Finish adding this plugin. There we go. Nope, that's not it. It's weird. Oh yeah, that's it. So why is it hard returning on those lines? After can. Yeah. But it's also after once all. Is there a new line here that we're missing? Odd. So we're looking at trait plugin. It looks fine. Must be just a weirdness around the LLM. Don't know why it would be doing that. Okay, enough sidetracks. Enough sidetracking. We might need to convert the physics plugin to a plugin struct in order to make this work. I do believe is physics a reserved like Bevy importy thing? Nope. Is it better not to name things with the plugin sub thing? Isn't there a linter rule that they're coming up with to prevent that? Naming my plugin, accessibility plugin. Yeah, maybe we do name it with the plugin. Okay. The plugin struct pattern is required here to define finish. I think I can't see that we would be able to do it here. What we will do is this. And then we'll remove this. This will be public. And in lib, oh, we're in the wrong directory. This will become physics plugin. Nice. All right, so render app needs an import. So does this. We'll fix that in a sec. Add the compute node as a top level node to the render graph. This means it will only execute once per frame. See I always end up with the same example. Shaders. GPU readback. May as well leave documentation for ourselves, because that's the kind of programmer we are. Huh. Let's check to make sure we have the imports we need. And a bunch of things we're not using yet, but we probably will. We don't need screens for now. I don't think we need that comment. Init resource. Compute pipeline is not a resource. So you say. But I think it will be. Now we also need these things. We're going to have like a collisions buffer, I think. So we're going to do, what do we call this? What do we call this? Collisions. Or collision buffer? Collisions buffer? Collisions buffer. Which does not exist. So our readback buffer was this. And one thing I want to determine is whether I can make that of dynamic size or not. My impression is that I can't. Okay, that fixes that problem. Now, let's add some more shit. Okay, so we've got our buffer. GPU buffer bind group. What is that? It's this thing. Derive resource GPU buffer bind group. Is there any good reason for me not to use that name? I think I want collisions buffer bind group. That's what I want. Prepare bind group. Let's look at this. What's the problem here? Compute pipeline is not a resource. Okay, we'll get to that. Readback buffer. These are all imported, right? Oh, it's breezy out there. Wonder if that's blowing across the mic. Huh. Readback buffer. Oh, I see. This is actually collisions buffer. And we don't want readerback image yet, at least. Now, compute pipeline is also something that they've defined. I think. Yes. So I think we'll call that collisions pipeline. And if we need more compute shadery stuff, we can change that later. Oh, we got ads. My lurker can enjoy the ads, which they are totally not watching anyway. Okay, cool. So this is collisions buffer bind group because we like naming consistency. We're very fond of it. Where would I be using images? I see this not. Use a unary type instead. That's so weird. Huh. Okay, compute node label. This looks useful. Again, collisions node label. And compute node is the node that will execute this compute shader. Oh my goodness. We're down the rabbit hole now. We are down there. But it's going to be fine because we're learning. We are learning. Okay. Drink more. Drink more. Feed brain. It's okay. Right. We have an hour left. A little over an hour, maybe. Okay. Let's see what we can get done. Add this compute node as a top level node to the render graph. See this. Yeah. Cool. So we've got rid of the errors there. And this is now looking a little cleaner. We've just got this bind group entries thing. Sequential. I wonder if there's like a type for a single bind group entry. What are you chewing on, puppy? Are you a good girl? Was that not to your liking, what you just chewed on? Okay. Buffer is entry is entire. What the hell? I don't like buffer. Boop-a-doop-a-doo. There isn't. Available fields is O. Huh. How do we make that work here? How did we make that work here? Buffer is entire buffer binding. Where is this defined? So buffer is, oh, I see. Buffer is buffer get and buffer O unwrap. Okay. I see. And buffers is not GPU share. Wait, hang on. GPU shared storage buffer doesn't exist anymore. We changed that to. Oh no, yeah, this is totally Bevy's thing, not mine. Okay. Hmm. Let's go with shader storage. Just want this naming to be really clear if possible. Yeah. And for some reason, it works if you do this and pass a sort of fake empty tuple, which I find really weird. So what are the other types of bind group entries? Sequential with indices. I see. Into binding array. Hmm. How could we just pass one thing? Let's look at usages of bind group entries sequential. There's one. And there. But they're all passing two things. What if I just want to pass one thing? Needs to match the bind group layout defined in the post-process pipeline. Everybody's passing more than one thing. What if I use with indices? Oh, like that. No? No. Can it? It's really confusing. Okay. Let's keep doing it like this and see what happens, I guess. Okay. Okay, so that's creating the storage texture with some data, but then we're not using the storage texture at this point. But for the buffer, we are. So let's go to init. Let's create init. Where is that in the plugin? Setup. Inset, render set, prepare bind groups. Yep, we do that. Setup just runs on startup. Okay. That seems fine. I'm prepared to run that on entering in-game, I guess. Does it matter that it exists first, I wonder? Add systems. On enter screen in-game init. Then we're going to go with 36 function init. And we're going to need mute commands and mute buffers. Res mute assets shader storage buffer. Okay, create a storage buffer with some data. Now, buffer size is 16 on that one. It could be a couple of hundred, but let's just go with 100. Well, hang on. Because if we have 100 characters, then we need 200 in the buffer so that we can have an identifier and then a true or false bit. Okay, so let's go with let collisions equals vec U32 and 200. Figure out magic number avoidance later. Also, can we use a dynamic sized buffer with web builds? Yeah. Oh, it does a shadow. I didn't know you could do that. Huh. Reuse is the name. Let's try it. Not sure I'm wild about that, but yeah, let's try spelling it right, eh? Is it possible to do this? I guess so. All right. Collisions. Oh, wait, it does need to be mutable. Buffer description. Usage. Buffer usages. Copy source. So we can copy the buffer to the CPU. What if we need to copy it to the GPU? We would need both, right? I don't know. Let's try it. Do we need dest here? Why do we need this buffer value now? It's 3 shadows so far. 2 in this case. Let collisions equals buffers add collisions. Rust shadow redefine variable. Declare a new variable with the same name. Shadows the previous can assign a new value to the new variable while the old one remains unchanged. Huh. Interesting. I did not know. Is this new or am I just way, way behind the curve as usual? Spawn the readback components. For each frame, the data will be read back from the GPU asynchronously and trigger the readback complete event on this entity. Despawn the entity to stop reading back the data. That's so cool. Okay. Observe trigger readback complete. This matches the type which was used to create the shaded storage buffer and is a convenient way to interpret the data. Okay. This is just a simple way to pass the buffer handle to the render app for our compute node. What's a buffer handle? Yeah, it's not an image handle, it's buffer handle. Yeah, that makes sense. Okay. So we insert resource. Do we ever init that resource? We do. But we do it in oh, that's for compute pipeline though. Huh. Okay. I guess we don't init this resource. So we just need to make sure that nothing ever accesses it before on enter in game, I guess. Yeah. Okay. All right. To make sure nothing accesses this, I suppose we could just add a default resource before screen on enter screen in game, or else init the resource with a default. All right. Sounds correct. Lots of to-dos. Lots of, I'll understand this later. Okay. So buffer length does feel like it needs to be it needs to be a constant, but figure out config values constants. All right, and then this is collision buffer bind group. Okay. Good. Shader asset path. This is from world for compute pipeline. Hey, Fanny Slam, how you doing? You don't mean repossession, but I could be a repo man. You don't know. You just don't know. I haven't had a chance to check that whether you've got an invite for me or not yet either. I should do that. Maybe I do that now. Repo man by day, repo man by night. Actually, you might not want me to do that on stream. That's a bad idea. Let's do that later. I'll check my notifications when I get to work. Shader path. So when we look at playing, we have this. Why is it complaining about that? Oh, I see. You hardly knew her. I made the cargo road joke again today. I can't stop. This is shaders collision. WGSL. This is not required, nor is this. A classic, a true classic. It's embedded in my psyche now. Wow, have we actually got rid of all of the errors? How did that happen? How did that even happen? It won't do anything yet though. So let's look at collision and let's just insert something temporary. And we want the storage texture. And instead of calling it data, we would like to call it collisions. That's our storage buffer. Okay. Use the global ID to index the array to make sure we don't access data used in another workgroup. Huh. Workgroup size 1, you say? Write the same data to the texture. We're not going to do that. Okay. Yeah, I think that's right. At some point, though, we are going to need to pass a image to it. We'll figure that out. We'll figure that out. We're not there yet, but we'll figure it out. We're not there yet. We're not there yet. We're not there yet. I wonder if I ran it now, would it just explode? Would it just explode? Would it explode? It would explode, right? It's going to explode. Oh, collisions buffer bind group does not exist in the world. Okay. It exploded. I hope you're chewing on something legitimate under that desk, Tilly, and not, power cables. Not power cables? No, good. All right. Oh, Ted's got his foot on a power cable, though. That's not ideal. Hey, dude. Yeah, good boy. Thank you. Good boy. Yeah. Trouble is, the camera doesn't point that way. So if I show me what's in your mouth, choose fast. If I turn the camera on, all we get is the wrong end of you. That's the wrong end, dude. You're all the way under here. You're down here and I can't point that way. Nice legs. He's got excellent legs. Tilly's not even she's way miles away. Hey Tills. Tills, you want a snack? You want a little snack? Hey Tilly, you want a snack? You want a snack? You do want a snack. Oh my god, your ears are ridiculous. Oh, now Ted wants a snack. He's like, hey, wait a minute. There were snacks and I didn't get a snack. What's going on with this world? What's going on with this world we live in? I didn't get my snack. Now I got it. Ridiculous. Ridiculous animals. They haven't been for a walk yet, so that's why there's much activity going on. Mucho activo. He's like, oh, I can go back to sleep. Okay. All right, let's see what we can get done here. Add the compute node as a top level node. Yes, blah, blah, blah. Collisions buffer, add plugin, extract resource plugin. Yes. What have I not done that I needed to do? God damn it. I started talking about the dogs and now I've forgotten what the error was. Collisions buffer bind group does not exist in the world. Did you forget to add it using app insert resource? Collisions buffer bind group, which over here was GPU buffer bind group. Oh yeah, this thing. I think I've encountered a timing issue. because I do have that. Collisions, buffer, bind group. There it is. It's totally there. But compute pipeline, I don't think that's called that anymore. Oh, it is, but it wasn't going to be. We were going to call it collisions pipeline. Thanks for the lurk, Fanny. I hope you're having a good day. Okay. So we add the pipeline, we add it on finish, and it doesn't exist. So if we look at GPU buffer bind group, it's insert resource on prepare bind group. We're not running prepare bind group yet, or are we? Here we are. Right here. Oh, insert render set prepare bind groups. Is that a thing? I think it is. What else could I be missing? Hmm. I think it's a timing issue. I think something I'm running in the wrong schedule is trying to access it before I'm ready. Maybe in the from world? Hmm. Why do I have to do that? Why can't I? Hmm. That's weird. Okay, so we're out of errors, but we need a correct label here. So um, collisions compute shader. It's interesting that it can't find it. I must start using it before it's ready. I wonder if the extract resource plugin needs to be added on startup instead. I wonder if init needs to be added on. Yeah, I bet it does. Nope. Oh, number of bindings does not. Oh, the bind group layout's wrong. Okay. Well, that's a new error, so that's good. Bind group layout. Bind group layout. Yeah, because this is the same problem that I was having before. Because I don't know how to pass just one thing. Maybe by getting rid of this entirely? Expected bind group entry found buffer binding. Yeah. I don't suppose. No. So how do I pass just one thing? Maybe just a bind group entry? Is there an example that uses bind group entry that I could copy? Good start. Need to go to shop and get milk for tea. This is essential. This is indeed essential. Could I create one? Bind group entry binding resource. So could I go? Looks like this should be simpler. Like everything. So it's complaining because it's expecting one thing and I'm passing it two things, right? Because I'm passing a tuple with nothing in the second part of the tuple, basically. Create bind group. Number of bindings in bind group descriptor 1 does not match the number of bindings defined in the bind group layout. And still can't find collisions buffer bind group. Hmm. Oh, really? Don't tell me that actually worked. Okay. Binding and reason. No, no, no. I think that's resource. And binding 0? That feels way too easy. Expected binding resource found buffer binding. Wrap the expression in render resource binding resource. I'm so confused. What does as entire buffer binding give me? Return the binding view of the entire buffer. Fair enough. I wonder if it's required. I see. Okay, what happens if we run now? Bad things. Number of bindings 1 does not match number of bindings defined in the bind group layout. 2. Okay, so it wasn't that was the problem. Is it the shader itself? Group O binding O. Workgroup size 1. I don't know where I define that it's going to be 2. Where do I define that it's going to be 2? Set bind group O, nothing. This could be collisions, compute pass. Dispatch work groups 20011. X, Y, and Z denote the number of work groups to dispatch in each dimension. Huh. Where do I define? Is there anywhere that defines the 2 parts to this? Or am I just using the wrong shader? No? Shaders, collision WGSL. Somewhere I'm telling it that there are 2 bindings. I don't know where. Bind group entries is there. Get buffer O, unwrap. Starting to run out of time here, but we still got a little bit longer. And then we've got to get our brain into AWS and Go. AWS, Go, and GitHub. Where might I have specified that there was more than one binding? We add the buffer. That's not really useful for us right now. Is it possible that in the collisions buffer handle shader storage buffer? No, that's all we use. Hmm. So then we've got GPU buffer bind group, which is my collisions buffer bind group, and it contains a bind group. Which has an ID and a value. Is there any chance that it's reading GPU readback WGSL? It can't be, right? It's not even in the same directory. Group 0, binding 0. Prepare bind group. Buffers get collision 0. Sort this. Bind group is render device create bind group. Pipeline layout. Pipeline is res collisions pipeline, and the layout is bind group layout, which is just that. Okay. Render device create bind group layout. None. What is that? Oh, wait a minute. Here we go. Here we go. There. I missed that one. Texture storage 2D. So I wonder if I do that, whether I can just use the other syntax for this. And maybe I don't even need a tuple here. Tuple, tuple, tuple. No, I do. All right, well, let's say that the same thing applies here. Something like that. Nope. There was one more thing. Nobody said working with shaders was going to be easy. Nobody said it. Bind group entry sequential and then a tuple and then a comma. That looks correct to me. Bind group is render device create bind. Oh, I see. I'm missing this. Expected reference to that, and I found reference to that. I see. Pipeline layout, bind group entries. What happens if I just, maybe I'm just spacing on this entirely. Let's just do that. I have no idea why that worked, but it did. I was missing something stupid, probably. All right, so now the numbers should match in theory, in theory, in theory. Hey, it runs. Oh my God. Just out of curiosity, are we getting... Oh my God. That's so cool. Look at it. It's working. Kind of, only not really. It's a buffer of 200 zeros. Exciting. All right. That does feel like a good place to wrap up before anything else goes wrong. Okay, so we need to add yes to that, to that, to that. We are not going to be able to do any music today. I don't have time. Shaders collision, yes. Add a rudimentary compute shader for collisions. Holy crap. I mean, we haven't collided anything yet, but that's neither here nor there, quite frankly. It's neither here nor there. Wow. Get LFS just slows things down so much. All right, so just out of curiosity, if I was to change this to not be on startup anymore, but instead to on enter screens in game, would that break everything? Why, yes, yes, it would. So we basically have to create the buffer ahead of time. And I imagine that that is going to make it difficult to state scope. That's okay. I think that's okay. That's okay. Do we really not use that? I guess we don't. All right. Move unused. And we we should record what we did in. Oh, I got an answer in my rendering question. Let's read that. Yeah, this is a bit of unfortunate naming. The ones in render assets are lower level wrappers around WGPU buffer. Shader storage buffer is a higher level asset meant for implementation, meant for integration with Asbind Group material. I like to use Asbind Group with compute, but we don't currently have a material like API for actually running the shaders. It's a long-term goal of mine. We support something similar in Nano, but it's a bit hard. Oh, I see. I see. So we'd attach a compute shader to some convenient item, much like we attach a fragment shader to a custom material. That would make some of this setup stuff a little more straightforward. I've arrived at the point where I can read back a buffer of 0. So we're making progress. I don't think I'm using Asbind Group in this one though, am I? Does that make shader storage buffer the wrong type? Okay, so let's go. Oh, hang on. She's still talking. They're still talking. What's happening? What's going on? Ah, here we go. This is what the game of life example looks like in Nanu. I don't even know what Nanu is. Oh, a creative coding framework for Rust. What? Oh, we went the wrong way. Oh, I see. I see. I see. I'm mostly following the GPU readback example, which uses shader storage buffer and bits of the game of life. We'll see if it breaks when I put it on itch. All right, so what did we learn? Oh, I might like. What might I like? Wait. Oh, shoot. I missed the interview. Oh, damn it. I have to watch the VOD. I completely forgot that was this week. Well, at the very least, we could rate in if he's still on. Wait, is he still on? Yes. Okay. Thanks for hanging out, lurkers and others. I appreciate you. See you next time. What happens if you raid in an ad break?